Okay guys, this is number 112 from chapter 7, and this is talking about why the electron affinities for these specific elements are so unfavorable. Electron affinity refers to the energy associated with the process of putting an electron into something. So beryllium, nitrogen, and neon all have endothermic electron affinities. This means it's unfavorable. It means I have to give energy in order for this to happen. So another way of saying this is that beryllium, nitrogen, and neon, they become less stable. They have a higher energy when an electron is added to them. So in order to figure out why that is, let's look at the electron configuration. So in beryllium, we have the electrons are in the 2s2. In order to add one, if I added one, it would have to go into the 2p. So that's putting it's putting the extra electron into a higher energy 2p atomic orbital because the 2s is already full. So it requires energy for that to happen because the 2s configuration for beryllium is already stable. Putting another electron in means it has to go up to a p orbital, which requires more energy. When we're looking at nitrogen, right now nitrogen is relatively stable. It has a half filled. This p orbital is half filled, which is a relatively stable configuration. If I added an electron, it would have to double up into one of the already occupied p orbitals, because that 2p orbital is going to look like this. And it would have one electron in each. If I forced an electron into that, it would have to double up. This is a higher energy configuration than the half-filled shell, so it would actually be unfavorable. Now when we're looking at neon, neon's noble gas. So the added electron for neon actually has to go to an entirely new energy, like an entirely new principal quantum number. The 2s and the 2p are full, so that extra electron would actually have to go into the 3s. Neon is very stable because it's a noble gas, and forcing an electron onto it into an additional orbital at a higher energy level would be much more unstable and an unfavorable reaction.